All right, we are back, and this is 8.1, day 1, video number 3, so make sure you watch them in order. We're starting out with problem 2b on the back side of your 8.1 notes. So if you look here at this equation, it's quadratic because we do have a quadratic term. Our a term is 1, our b term is -8. Our c term is, right now, 18. But remember, if we're going to use the complete the square method, we have to rewrite this in the form ax squared plus bx equals -c. So we have to remove this c right now by subtracting it to the other side. So if we do that and rewrite it in that form, I'm saving some space because we're going to complete this square and make it a perfect square. So I know I'm going to have to add some term, and whatever I do to the left side, I'm going to do to the right side. And right now what we're going to do is we're going to use our little formula to find our constant that will make this a perfect square. So we're going to take our b term, which is -8, divided by 2, and square it. So we have -4 squared, which is +16. So we're going to add 16 to both sides. Okay, now on the left side, we have a perfect square. So we're going to rewrite this in factored form. So again, this is r and -4 and -4. So we have r minus 4 quantity squared. So we just rewrote the left side of the equation in factored form because we had a perfect square. We made this by completing that square. And equals -18 plus 16 is -2. Now we're going to solve our quadratic equation by using the square root method. So if I square root both sides here, the square roots and the square cancel each other out. So I'm left with r minus 4 equals, and then I have the square root of -2. But recall that the square root of -2 is the same as the square root of 2 times the square root of -1, which is, stays underneath, plus and minus the square root of 2i. So to solve for r, we're going to see if we can add 4 to both sides. So we're going to add 4 to both sides, and when we do that, we're going to get r equals 4 plus root 2i, and also r equals 4 minus root 2i. And that is actually our final answers. Again, this is where they're separated, or we could rewrite them as r equals 4 plus and minus square root of 2 and then I. Remember that the I is technically not underneath the radical, and these cannot be added because they are unlike terms. Okay, moving on. We have problem C. So problem C is one of those problems that this doesn't look like it's going to be a nice number, but we'll see. If we rewrite this to complete the square, we're going to have to remove this constant and bring it over to the right side by subtracting it. So we're going to end up with a squared minus 5a equals -3, because we need to make room to complete this square to make it a perfect square trinomial. But what we do to one side, we have to do to the other, so we'll see what we have to add in there. All right, so this is our a term, which is 1. This is our b, and this is our, well, our c is what we're trying to do. We don't know what it is, okay? All right, so we're going to take our b term, which is -5. Always grab the sign in front, divide by 2, and we're going to square it. Now, -5 halves squared is the same as -5 squared, which is 25, and then 2 squared, which is 4. So 25/4. So believe it or not, we're going to fill this in with plus 25/4. And it's not pretty right now, okay? So we have some work to do. So the nice thing about this is when we look to see how the heck do I factor that? Well, we have a times a, and they both have to be minus signs because we need a positive when multiplied, negative when added. Believe it or not, our answer is going to be -5/2. So we have -5/2. So all I'm going to do is put that in, and then so to rewrite this in a perfect square trinomial in factored form, it's a minus 5/2 quantity squared. Let me rewrite that because that looks like a little different than it's supposed to look. So we have a minus 5/2 quantity squared equals, now I have -3 plus 25/4. So I can't just add that like we know. We have fractions here, so we have some work to do. We have to get a same denominator. So if I multiply this side by 4, I'm going to get the same denominator of 4, which means I have -12/4 plus 25/4, which is 13/4. Okay, so I have equals 13/4. All right, all that work for that little piece. Now we're ready to solve. Since we want to solve for a, we're going to have to get rid of this square by taking the square root of that. And again, what you do to one side, you're going to have to do to the other. So the square root cancel out, so I am left with a minus 5/2 equals, remember that the square root of 13/4 is the same as the square root of 13 divided by the square root of 4. And the square root of 13 is the square root of 13. But we took the square root, so remember it's plus and minus. Now the square root of 4 is just 2, so that's nice. It works out nicely. We have to solve for a, so we have to get rid of -5/2 by adding 5/2 to both sides. So then what this looks like is that a equals 5/2 plus and minus the square root of 13/2. So that would be our final answer. But you may see it in the book as two separate answers. So it would look like a equals 5/2 plus the square root of 13/2, and a equals 5/2 minus the square root of 13/2. So that's how they write them separately, or you could write it together. Okay, this is the end of 8.1 day 1. So your homework is 8.1 day 1's homework. Thanks.